Hey guys, the objectives for this video is to look at an over-consolidated soil, and we're going to be doing an example where we find the final voids ratio. Okay, so we know that from our previous video, the over-consolidated soil is when the pre-consolidated stress is greater than the current stress we're experiencing. Okay, at a time zero or anywhere along this line at a particular time. Okay, so let's say, for example, we're given this information. Let's say we're given that the sigma initial, so sigma subscript I, so the initial effective stress is 40 kPa, the final effective stress is 60 kPa, and the pre-consolidated stress is 80 kPa. Okay, so if I were to draw this, okay. Once again, I'm drawing the effective stress against the voids ratio. So here's my line. I would initially be at 40 kPa. So sigma I is 40. Okay. I then increase, so over time I then go to 60. So my final effective stress is 60. And I know that my pre-consolidation is 80. Right? Sigma PC is equal to 80. Right? So what this is showing is that, so that originally was at this time equals 0, now I'm increasing. Here's my time equals 0. Okay, so at the present time, my stress I'm experiencing is 60, but I know that the maximum stress my soil sample has ever experienced is 80 kPa. Okay, so on the grand scheme of things, I'm actually on this line here, right? I haven't yet gone beyond the pre-consolidated stress. So if they give me the information such that my final effective stress is less than the pre-consolidated stress, I'm on the over-consolidated line. Okay? Another thing they could do, instead of giving this information, they could just say that my soil is over-consolidated, which means that I'm definitely less than the pre-consolidated stress. They could do one of two things. They could give me the information, and I have to interpret that I'm overly consolidated, or they could just say I'm overly consolidated in the question. So why do we need to know the difference? The difference is because we need to know whether we're using this CR term or this CC term. Okay? So if we were to do this example, because we're overly consolidated, we'd be using CR as our gradient. Okay? So let's do a quick example using numbers. Let's say they give us the information that CC equals 0.4 and C subscript R equals 0.06. Okay, and we're going to be using these values. And let's say that our initial void ratio is 1.1. Okay, they want us to find this final void ratio. So they want to know E final, right? So because this is a line, we can develop an equation for the gradient. Just a note, this effective stress is a log scale. Okay, so we could write, if we wanted to find the gradient of this line, we could go EF minus EI on top of log sigma F minus log sigma I. Okay, this would equal the gradient CR. Okay, because CR is more often than not given in a positive number, we're putting a minus out the front. Okay, to make it because this slope is obviously negative, we're going to get a negative answer. If we put a negative outside a negative, we get a positive number, because CR and CC are always given as positives. It's just the notation that we're going to be using. Okay, so this equation develops the gradient for this curve, which we can rearrange to get E final in terms of minus CR log sigma F dash on sigma I dash. Okay, because we're log minus log, we know by log rules that we can go log of that divide by that if it's minus, so I've just done that there, and this is plus the initial void ratio. So we can, by plugging everything in, we can find our final void ratio. We're given CR equals 0.06, so minus 0.06 log, this is log base 10, sigma final dash, we've been given as 60, so 60 on sigma initial is 40, plus the initial void ratio, which we said was 1.1. So plus 1.1. If we go ahead and calculate this, we find that our new void ratio is 1.09. Okay, so with our initial void ratio is 1.1, so we're going to be decreasing. We're going to be increasing effective stress, which means that our void ratio will be decreasing and we get a smaller number of 1.09. Okay, so this example is how you find the final void ratio if your soil is over consolidated. In the next video, we're going to be looking at what happens when our soil is normally consolidated, how we find the void ratio there. And yeah, I recommend you watch that video. Hope that helps, guys.